de Broglie wavelength. Now, what is de Broglie wavelength? We have to know first what de Broglie said. Okay, de Broglie said that if a moving charge particle or electron, it has two natures. One is wave nature, one is particle nature. So it has both. So from this, we see in Planck's on equation E equal to h mu, and we also know here E can be written as mc square, because from Einstein's equation we know E equal to mc square. So H can be written as hc by lambda, because mu is equal to velocity by wavelength. So what happens? This equation comes here. De Broglie modified it, written it like this. So it is our de Broglie's wavelength. Okay. Now this equation can also be modified. That is half mv square if we equal to k. Okay. Now we know that momentum can be written as like this with respect to our energy. So this equation will be modified like this: h by root over of 2m. Okay. So here de Broglie wavelength is done. Now we have to discuss about Heisenberg's uncertainty principle. And what did Heisenberg said? That uncertainty in the position into uncertainty is momentum of an electron, that will be greater than or equal to h by 4 pi. Now this equation in NEET, they will give you value of something of uncertainty in position and uncertainty in this, and they will tell you to deduct something from it. So there's a specific question that comes from it, that they will give you this question, that if momentum and uncertainty in the position is same, then what is the value of uncertainty in velocity? So you can conclude it like that: del x into del p, here we are assuming it is equal to h by 4 pi. So here we can write it like this, because mass can be changed, so obviously uncertainty in velocity will be product of this. So equal to h by 4 pi. So it will be m square into del v square equal to h by 4 pi, or del v equal to h by 2m to root over of 1 by pi. So what this comes, This comes root over of h by pi into 1 by 2m. Okay. So now we are gonna discuss quantum theory of atoms. So for quantum theory of atoms, there are certain quantum numbers. So first is our principal quantum number. What does it indicate? First, it indicates the location of the electron. Okay. Then number of subshells it also gives, that is n in the nth shell, and we can also deduct the number of orbitals from it. What will be that? N square. The number of electrons in the nth shell, that will be 2n square. Okay. So it is our principal quantum number. So next comes our azimuthal quantum number. So for azimuthal quantum number, it is deducted as L. Now its value can be anything from 1, 2, 3, 4, but not exceeding n minus 1. Okay. So if L is 0, so it is deducted as S. Okay, S orbital. It comes. So S orbital has a shape of a sphere like this. The shape of a sphere. Now, if L comes 1, it is denoted as p orbital. P orbitals are three types: px, py, pz. So you can draw them like this. That px, let us suppose this is px. Okay. So this is our py. And from here comes another. This will be our pz. Okay. So, but what happens if L is equal to 2? Then it is come d orbital. Now d orbitals is 5 in number. First is our dxy. It comes like this. Second is our dyz. Third is our dzx. It comes like this. Zx. Fifth is dx square minus y square. It goes through the axes. And last and most important, dz square. Now we're going to discuss about magnetic quantum number. That is m. Now m, this value comes from minus L to plus L. That means if L equal to 0, then m equal to 0. But if L equal to 1, m can be minus 1, 0, plus 1. If L equal to 2, then m's value can come from minus 2, minus 1, 0, plus 1, plus 2. That is why S has 1 orbital, P has 3 orbitals, D has 5 orbitals. Okay, so it is deducted from this. Also, magnetic quantum number gives the orientation of electron in the space. Okay, now fourth is our spin quantum number. That is spin quantum number. Now for spin quantum number, it has either value of plus half or minus half. So here quantum numbers are done. Now we have to see some rules to write electronic configuration. What above said, that electron in a subshell is filled in increasing order of energy, or n plus L rule. So what is n plus L rule? That if n plus L, that means sum of magnetic and azimuthal quantum number, the orbital who has lower value of it will be filled first than the upper value. That means if one has 4s and one has 3d, so what is this n plus L will come? It is 4 plus 0 will be 4, but it will be 3 plus 2 equal to 5. So the 5, the 3d orbital will be filled first and 4s will be filled after this. But what happens if this comes like this? So n plus L value is same, right? So which will be filled first? So here is a special exception, that which has the lower value of n, that will be filled first. That means this has lower value of n, right? So here 3p orbital will be filled first, then the 4s. So here goes our Abba's principle. Now we will discuss about Hund's rule. So what Hund said, that electron is an orbital is first filled singly, then gets paired. That means if we draw here a p orbital, so if it is filled like this and another is filled like this, so which is correct? So according to Holden's rule, energy distribution should be maximum. So you can see that its energy distribution can be like this, but its energy distribution is this. So one of the orbitals is empty, so energy distribution can happen here. So this is more stable and this is less stable. So Hund said that first the orbitals have to fill singly, then they can be paired. So this is wrong, because it is not singly filled all. but then how can it be paired? But it is all singly filled, see. So here we can just add another electron, so it is correct. Okay, so here our own rule is done. Now we have to know about Pauli's exclusion principle. So what Pauli said that if three quantum numbers are same, then the fourth one must be different. That means if n equal to 2, then n equal to can be anything from 0 to 1, but it can be 2, right? Then m also can be minus 1, 0, plus 1. Okay. And s is also can be plus up or minus up. So you can see that no quantum number is coming same. So if it comes 2, 1, 1, then the spin quantum number comes different. Or if we see that 2, 1 comes, then we can see that plus 1 will be cut, so it will be anything from minus 1 to 0. So it is our Pauli's law. So now we have to know how to write electronic configuration. So for that we have to know its atomic number, right? O, O2, oxygen's atomic number is 8. So from that we can write that s orbital, first is our 1s, then 2s, then 2p. So here electron is filled like this. So what will it come? 1s2, 2s2, 2p4, 2 plus 2, 4, 4 plus 4, 6. So this is how we write electronic configuration. Now about the nodes. This is a very important question in NEET. There's a formula that is for radial node, it is n minus l minus 1. For angular node, what will be it? It will be only L. So what is the total number of node come? That will be n minus 1. So this is all for atomic structure.
To learn difficult concept of physics, chemistry and biology within few minutes to crack NEET and JEE with fun, like, share and subscribe our new YouTube channel Shantu. You will get conceptual videos, highly effective notes, short tricks, mock tests and much more. Hope we shall meet there.